Okay, so the purpose of this lab is to investigate accelerated motion, but it's also to kind of review a bit of our graphing stuff. Okay, with the exam coming up here soon, we want to be able to review position versus time, but most especially velocity versus time graphs, because obviously we've already done a lab with position versus time. This is kind of our lab to do with velocity versus time graphs. All right, so the problem we're investigating, what type of motion is experienced by a cart rolling down an incline? Spoiler alert, it's probably in the title. Okay, yeah, I know, it's kind of a cookbook lab, but we have to do the analysis here, right? All right, so we got to identify our manipulated, responding, and controlled variables. So the lab's going to work like it is in this picture, except we're going to be using the wooden ramps. Okay, so we'll have a cart on the ramp. The ramp will be slightly inclined, very slightly. It does not need to be heavily inclined. In fact, you don't get as good a data if you have it very steep. Okay, so just a small incline, and we allow the cart to run down the ramp while the little position meter we used before records both its position and its velocity as it goes down the ramp. Okay, those are the only well, we'll need time, position, and velocity, okay, as our things that will be measured by the device. If those are the things being measured, they usually end up being variables that are important in the lab. Okay, some of them might be manipulated and some of them might respond to that manipulated variable, and well, one of those three that I just listed is almost always the manipulated variable when it's present. Okay, all right, controlled variables, things that need to stay the same throughout the experiment. The experiment is only going to be one run. Okay, you're just going to run the cart down the ramp and get the data. So doing the experiment part of this doesn't take very long. You need one good run. Things that need to stay the same throughout that run are going to be your controlled variables. Right? One of them is controlled, but not by you. In fact, it hasn't changed in a very, very long time. Okay? But it does help this lab work. Without it, this lab probably wouldn't happen. There you go. You got one controlled variable, sort of, if you can get through my cryptic hints there. Okay. All right. For our hypothesis, okay, what three words need to go in there? If, and, then. All right. It's going to set up like this. In the if part of the hypothesis, okay, basically, you need to tell me what acceleration is. If we're investigating acceleration, the if part should tell me, you know, kind of in your own words, what acceleration is. Okay, the and part, as always, describes the experiment. There's a cart being run down a ramp while several things are being recorded. Probably mention what those several things are. And the then part needs to tell me how you're going to calculate the acceleration of the cart from the velocity time graph. Okay, so those are the things that should go in your hypothesis. Okay, so when we're doing the actual procedure, okay, with the wooden ramps, the sensor just sits on top of the ramp. Okay, it doesn't clip on like it does on the metal ones. Okay, so you're gonna set the ramp up, like one thick binder will be enough. Okay, or if you have just a couple of small ones, maybe put two on top of each other. Okay, but you don't, again, need this very steep. That 3 textbook one that I've got there is like about as steep as you would want it to be. Don't put it up on the seat of your desk. That will be way too steep, right? The cart gets to the bottom of the ramp before you get really good data because it happens so fast. Okay, so a small incline helps us get data over a longer period because it takes longer for it to get to the bottom. Everybody follow there? Okay. Now, in terms of getting good data, one of the things we found when we did the other lab was that the sensors detected lots of other things got in the way. Well, those carts went really slow and they were in a big open area, so there were lots of other things to detect. That will be less of a problem on this lab because it's only going to detect the cart on the ramp. To avoid it detecting anything else, what you'll want to do is release the cart by holding it from behind. Okay, so put it right up against the sensor and hold it from behind the sensor by the back or by the back wheels. And then when the person is ready and says go, just let it go. The sensor won't see your fingers because they're essentially off to the side out of its field of view. Okay, then let it go to the bottom of the ramp. Okay, it will run off the ramp and that's fine, but we only want the data while it's on the ramp. And you'll be able to tell when it's not on the ramp anymore when you look at the data. Okay, because what will it stop doing once it gets to the bottom? Well, actually, it'll stop accelerating positively and start accelerating negatively, because once it hits the ground, it's going to start slowing down. Okay, so we're only going to want the part of the graph where the velocity is going up. Okay, now we're also going to have position versus time data, and for an accelerating object, how should that look? Because that's the one you'll see on your phone when it's running. Right, it'll look like a curve. It might not be very curved, okay, but it'll be at least slightly curved. Okay, remember that you want to put an exponential fit on that line. Okay, when you're saying draw the best fit line on there, the trend line, you want that one to be exponential, and obviously you want the velocity versus time one to be what kind? Exponential, polynomial, or linear? Okay, I'm gonna let you figure that one out because that's something you should know. Okay. All right. So once you've got the data, same as before, share it with everyone in your group by sending it to their Redeemer email, and then you'll be able to access it, open it in Google Sheets like we did before, and you're going to build a position versus time graph and a velocity versus time graph. Okay, so you're going to have two graphs, okay, that you're going to build. Basically, you're just building the position versus time graph. We're not performing any calculations with it. Okay, it's just going to be used to prove that acceleration is going on by its shape. Okay, the velocity versus time graph, you will have to do some calculating because obviously in our hypothesis, we want to use it to calculate the acceleration of the cart. All right, and there's a way to get that from a velocity versus time graph. Okay, so in the analysis, question number 1, using your graphs, identify the type of motion that occurred in this lab and show calculations to prove and explain your reasoning. So here's what I want here, right? Talk about the shapes of the two graphs and whether they tell you the object is accelerating or not. And I'm also going to want you to show me a calculation here from the velocity time graph that shows how you calculated acceleration and what the acceleration's value was. Everybody follow there? Okay, so you're talking about the shapes, and then you're doing a calculation using the velocity time graph to prove acceleration occurred. Question number 2, okay, there's 2 ways to find the displacement of the object. One way using the position versus time graph, and one way using the velocity versus time graph. I want you to do both, and then compare the values. They should be what? The graphs of the same motion, they should be the same, hopefully, but they're probably not going to be exactly. Just explain any differences. Okay? If they're close, good. Okay? If they're exactly the same, wonderful. If you're off by 1.5 meters, you did something really wrong. Okay? All right. Then in your conclusion, okay, again, copy and paste your hypothesis, and then tell me, okay, from the shapes of my graphs, from the calculations that were performed, from this, from that, accelerated motion was going on or it wasn't going on, hypothesis accepted or rejected, you decide. Okay, and then for your sources of error and evaluation, okay, any sources of error, you need 2. Okay, 2 sources of error and ways to fix them. All right, that's what we're looking for that. Okay, any questions on the expectations there? All right, a couple of things with the Pasco stuff here, with the measurement devices. Remember that you don't want to have the SparkView app open before you connect this to your phone. Okay, so connect this thing to the position sensor. Okay, that's these. So connect them to the position sensor, then turn them on, then find them in your settings, in the Bluetooth settings, connect to the one that's got the number on it, okay, then open up SparkView. All right, if you have trouble, let me know. right? So you need to get this set up. You need to build your ramp. Grab a black cart, okay? Not the silver ones, the black ones, and then you can get started on it. You only need one good run. Okay, have at her.